So this is actually my first for real conference talk. Every other talk I've given has been internal or to small meetups or just groups of friends. So this is actually kind of exciting for me. Thank you, thank you. So I am a developer advocate with the Google Chrome team, and my explicit focus is Chrome extensions and the Chrome Web Store. So today I'd like to talk to you a bit about how Chrome is trying to evolve the extensions platform in order to make it more secure, stable, and reliable for end users. So the high-level overview of what I'm going to be talking about is a broad history of, well, an abbreviated history of browser extensions and customizability in the browser, Chrome's approach to extensions, and finally, what is changing in Manifest v3. So onto the browser history. Browser history is very long, very complicated. There's a ton of different stuff. So I'm going to be giving a vastly oversimplified history here. And if you're expecting something exciting here, don't be, because it is literally these bullet points. So first up, we have Netscape Navigator, Internet Explorer, and then Firefox v1. Each of these kind of introduces a new concept to browser extension and customization. And obviously, finally, Chrome with its own special take. So Netscape Navigator, wait, before I go on, one of my favorite things about this slide is the animation in the Navigator logo. I totally forgot. It's been long enough that when I was doing research for this and looking into the history of browsers, I forgot how common these kind of throb animations were, and it's an artifact of web history that I kind of miss. Anyway, Netscape Navigator was the first browser that allowed third-party developers to modify what the browser could do post-installation, after it was actually on the user's machine. And they did this through the introduction of a NP API, or Netscape Plugin Application Programming Interface. NP API was cool because it allowed third-party developers to register new content types that the browser could display and the user could interact with. So this was originally introduced specifically for Java applets, but later on, folks like Mozilla used this capability to add the ability for application PDF, or to display PDFs in a browser. So this capability was reverse engineerable and ultimately extendable by other third parties. But one of the disadvantages of this approach is that fundamentally they didn't really have a security model. This was just some native code running in the browser, executed in the browser's process, and it had the same capabilities. The threat model at the time was very different than what we have today, so that wasn't too much of a concern, but it was something to be aware of. The most practical side effect of this is if you had an unstable plugin, let's say maybe it was something like a PDF displayer, it might crash your browser unexpectedly. That was pretty not great as an end user experience. The next major phase we have here is Internet Explorer 4. Internet Explorer introduced this was the first time a browser allowed third parties to actually modify the browser's behavior rather than just the content that it could display. And before I go on, again, logo stuff. This in my head is what I think of when I think of Internet Explorer 4. It turns out this is actually like the IE6 and 7 logo in loading animation. IE4 actually had this modern style logo, which I find kind of funny that we started here and then moved away and went skeuomorphic and then came back to this super reduced minimal thing. Anyway, none of that's important. So one of the capabilities that they introduced in IE4 was this shortcuts menu or context menu. When you right-click, you were able to go to a menu and take an action that would be invoked in your extension. This was a nice bit of functionality, but not, I don't know, the end-all be-all. Internet Explorer also introduced Explorer bars, or in what some modern browsers call sidebars. So this is persistent content that frames the web UI that you're interacting with. Next up, we have toolbars. And you can see Google is one of the many providers of toolbars. This would typically be things like overriding your search provider, adding customization to, I don't know, common behaviors that you might have, or maybe even tabs, or what are they called? bookmarks. Of course, this could be pretty terrible, and you ended up with stuff like this, where, of course, Google is a contributor to this mess. Now, one of the reasons that we ended up in this situation is that in order to install an extension, you had to execute an installer, and that would drop a binary in your file system, and that would register, it would add a registry entry so that IE would know where to look in order to load your extension, which made it kind of hard for non-tech-savvy users to get rid of stuff. And with the capabilities of running in a binary, it also made it so extension developers could make some bad, not-so-great user interface decisions that made it hard to get rid of their tools. And finally, the fourth major thing that Internet Explorer introduced was this concept of browser helper objects, or BHOs. By and large, the entire extension feature is commonly referred to as BHOs, or an extension was commonly referred to as a BHO, even though the first three things, shortcuts, explorer bars, and toolbars, could be provided without a BHO. That's kind of an implementation detail, but whatever. The way this system worked is you would compile a native DLL that used a kind of standardized COM interface in order to communicate with Internet Explorer. And BHOs could then have this full set of native capabilities and file system access and, potentially owning a user's machine. Not the best security capabilities. Anyway, this one that we're looking at right now, the web accessibility toolbar produced by Vision Australia, it would let you do things like preview a grayscale mode or see what your web experience would be like for colorblind users, or expose in a visual way the accessibility tree. It was actually a pretty cool extension that helped a lot of developers. Firefox is kind of the next major step in the customization of browser extensions, in that this was the first time, well, there were a couple of interesting firsts with Firefox. Predating Firefox is a application suite that was produced by Mozilla called Mozilla Application Suite. Clever name. They basically had an email client and an RSS reader and a web browser and this package, and I think a calendar too, of this package of tools that a user could use to accomplish their day-to-day native work on their desktop. What was really cool about this is they used a user interface language called Zool, XML user interface language, and it could be scripted or programmed, scripted with JavaScript or programmed with XPCOM, which is a cross-platform component object model. Basically the same thing as the COM model that IE was using, except now it's cross-platform, and you can do more languages rather than just the specific things that would compile to the COM interface. Later on, oh right, I was talking about Mozilla Application Suite. That's also known as SeaMonkey, if you might have heard that term. SeaMonkey was interesting because the entire thing was scriptable using Zool and one of these languages. So they were using web technologies to build an entire web browser and application suite. What happened with Firefox is they took those capabilities and formalized them and exposed them as the extension platform. So it was possible to use web technologies to build the web browser, or it was possible to use web technologies to customize the web browser. They also tried to do some sandboxing here to limit the nefarious things that extensions could do, but ultimately it wasn't that hard to get full control of the browser with XPCOM and therefore do terrible things to the user's machine. Part of what was novel with Firefox here, though, is they introduced for the first time the ability to install extensions from the web. So this is a whole interesting potential vector for a new class of attacks. And again, like the previous ones, this is the XPCOM DLL that is being loaded in the browser is arbitrary binary. So again, you could do some pretty terrible stuff. So enter Chrome extensions. Chrome extensions were introduced in Chrome 4.0, which is very, very early on. I think maybe a year or two after Chrome was first released. The goals are listed here of the Chrome extension platform, but the main thing I want to call out is that Chrome is webby, it is stable, or Chrome extensions are webby, stable, and secure. So it's webby in that they're built with web technologies, HTML, JavaScript, and CSS. It's stable in that a fault in the extension isn't going to bring down the whole browser process. The worst case is the unstable extension will take itself down, and it'll die on its own in the corner. And it's secure in that it adopts the web security model with some additional modifications specific to the extension platform in order to increase the security of the additional capabilities that are exposed there. This is a fundamental shift from how everything, I guess, pre-Firefox. Firefox had a little bit of ability to do this, but they were still something different. They were using special technologies to build the extensions platform, where Chrome extensions are all just web technologies with some additional APIs. And I wanted to call out, this breaks away from native APIs with the small asterisk that content displaying capabilities, like we originally discussed with Netscape, it still supported NP API and some additional Chrome-specific stuff, NACL and PNACL, but those are going away in favor of WASM. So let's pretend they don't exist. I only care about extensions anyway. So moving on. No extension platform, no software platform is perfect. So in the intervening years between the original release of extensions and the current platform as we know it today, we started to see some patterns in the extension ecosystem of both abuse and user error on the part of developers, where developers would do things that weren't in their best interest. They would have accidental vulnerabilities. So in order to address some of those, we introduced some stuff like a web accessible resources field in your manifest JSON. Oh, I just realized I didn't actually go over all the contents of a Chrome extension. We'll get into some details later. So the main entry point in a Chrome extension is manifest JSON. It's a JSON file that defines the name of your extension, the current version, what files to run in the background, what files to inject into the page, et cetera. In Manifest v2, it introduced this web accessible resources, so only resources that you want to expose to the web context or other places would actually appear or be accessible. And this was addressing a common attack vector where people were able to use signals that are leaked by the extension in order to figure out which extension is running, and if knowing the exploits available on that extension could then hook in and do bad things to the user. Is there anything else I wanted to cover in that? Nah. Again, no platform is perfect. There were some issues here, even as we tried to plug some of these issues, or some of the exploits that existed. One of which was that if an extension in its background page loaded an iframe of a third-party website, that third-party website could use browser exploits to gain control of the extension and therefore have elevated privileges to do bad things to the user. The way that the Chrome team addressed this was by separating the iframe process from the extension process, so they no longer share the same memory and can't be directly accessed. More broadly, site isolation is something the extension team and Chrome team are very concerned about. We removed the ability to perform inline installation. So previously, it was possible to visit some website, let's say buffer.com, and to click the Install Chrome extension button, and then suddenly you would have the Buffer extension installed in your web browser. Of course, a malicious actor could have Buffer with 3 Fs rather than 2, directly clone their website, clone their extension, and then add a little bit more code that allowed them to exploit the user, and the end user would be none the wiser. The end user thinks they're doing everything correctly. It appears that they're doing everything correctly, but unfortunately, they've just given somebody else the keys to the kingdom. The final thing that I want to call out in improvements that we've made to the current extension platform is changing it so that extensions that are loaded in the browser the user has more control over when and how they run. So right here, I'm interacting with the, Google Dictionary extension, which lets you define terms on a page. And I know that I work with some sensitive data, so I don't want to expose every page that I visit to it. I only want to say expose google.com. In that case, I can right-click the extension, go to this can read and change data, site data, and then select the specific sites where I want the extension to run, or only run the extension in response to clicking the extension's browser action, the icon in the toolbar. The ultimate goal here is that we're giving users more control. This change was made in Chrome 70, and in the future, we're planning to change it so by default, when you install an extension, it will not default to all sites. It will default to the most limited set of capabilities. Now, I talked about some of the things that we've done to address limitations of Manifest v2, but there are other things that we can't quite address here. For one, there's not enough focus on usability. When the Chrome team designed the extension interaction patterns, the platform, there was a fundamental assumption about how users interact with install prompts. And I think an assumption that people read all the words and understand them and make informed decisions. That's not always true. Unfortunately, I think in the intervening years, we've seen that users don't quite understand what read and modify all site data means, for example. And that's an extremely common thing because all URLs is extremely common in the extension ecosystem. The all URLs permission allows an extension to eject content scripts on any site that you visit, and in some cases to kind of supercharge other APIs that the browser exposes. So the tabs API, for example. Actually, tabs is a bad example. Ignore that. Pretend I didn't say that. But in general, all URLs is too common. It is a very powerful permission. It is, unfortunately, currently the only way to do some things like passively inject UI into a page. And when it's too common, that means that we can't detect anomalous use of this permission because everybody requests it. One of the major things that has been in the news recently is that remote code injection in an extension is currently allowed, and it's kind of a problem. But it's a problem that we don't think we can address on the Manifest v2 platform because it breaks some fundamental assumptions about how extensions work. So that's why it's going into this, this platform version bump. Effectively, if an extension loads code that isn't bundled in the extension's executable, then it can do anything at any time, and we can't know about it or react to it very well. In fact, the thing that it does today might not be the same thing as it does tomorrow, or the thing that it does for me might not be the same as it does for you, which is, I think, a pretty bad world to be in. I mentioned this a bit in discussion of all URLs. Powerful APIs are currently your only option for a lot of capabilities. That is, for a content blocker, say, in order to allow a content blocker to block a website, I have to give that content blocker access to the websites that I want to block, which means that it could potentially perform who knows what actions on those sites without my knowledge or consent. This is more of a Chrome issue, but extensions can tank performance and tank it in a way that's not terribly obvious to the end user. So by a developer not coding an extension in a performant way, they can unintentionally make the entire browser experience significantly worse. And finally, users don't have enough control over their experience. We addressed some of this, or we're trying to work through this with the upcoming change I mentioned to default to restricting all URLs to only on-click, but that again, is going to require a version bump in order to actually tackle. So I think it's fair to say that we are not in a situation that we want to be, that the extension platform is more vulnerable kind of by design than it should be. And to that end, we're introducing Manifest v3, which will shift some of these base assumptions about how the platform works. So the broad strokes, the goals of Manifest v3 are to improve the security, privacy, and performance of the Chrome extensions platform. For security, we want to improve the security guarantees. That is, we want to be able to say with confidence that it is significantly harder or impossible for a malicious site or extension to gain control of these privileged execution environments. And by extension, to increase end-user trust that when they install an extension, it isn't going to do anything harmful to them without their direct involvement, and that they can easily remove an extension and it won't cause any lasting harm. For privacy, we want users to have more control over their experience. So for privacy, we want the user to have more control over what sites an extension is executing on. And part of that is going to be a shift in, or trying to encourage developers to shift how they expect their extensions to run. Rather than passively running all the time, we want extensions to move to a model where they're running in response to user action. So the user is ultimately the one that's in control. And for performance, we want extensions to be performed by default. We want developers to fall into a pit of success, where even if they don't know what they're doing and they do some anti-patterns, worst case scenario, that things will kind of work out for them anyway. And by extension, reducing the amount of resources that an extension is using over the course of its life. So at this point, I want to get a bit into the specifics of some of these changes. Runtime host permissions, that is the ability to inject script into a site. We want to, as I said, move to click by default. We have a permission in the Chrome extension platform called active tab that a browser can, or an extension can currently choose to opt into active tab style permissions, where when somebody clicks a browser action or hits a global keyboard shortcut or hits the Omnibox shortcut that they've registered or triggers a context menu entry, those are the 4 ways that you can get active tab. Only then does the extension have the ability to run. And for extensions that do require or need to passively inject, there will be a way to do that, but it isn't going to be the primary way that most extensions are expected to operate. This is challenging, though, because it is a shift in the extension architecture. It will require developers to make a shift in their architecture in order to be more evented and more contextual. So again, in the future, when you click, the extension will be the default option. At install time, they're still working on the UI for this, but at install time, it will have an option. It will present the user with an option that says when you click the extension, and they will have a way of changing that to automatically run on all sites or on specific sites. And then developers will also have a way of checking their current permissions and then re-prompting the user if they don't have enough, if they can't do their job, basically. Another significant change that we're making is replacing the web request, the blocking version of the web request API with a new API called Declarative Net Request. For the most part, most of the capabilities of the Declarative Net Request API don't actually require host permissions. So again, we're limiting the potential vulnerabilities and attack vectors by just giving extensions less right out of the gate. But fundamentally, web request is more capable because it's an imperative API. You can literally write whatever code you want, and it will do it. Whereas the Declarative Net Request API, it's declarative, so there's a limited set of capabilities that you can actually execute. One of the benefits to this from a performance point of view is we're getting extensions out of the web request flow, which means we can heavily optimize how network requests are processed by extensions. Currently, it takes several process hops in order for an extension to even get notified that a request is being made, and then they have to execute some logic and then pass it back to Chrome, which takes a couple more process hops. All of this is potentially, depending on implementation details, potentially all able to be executed on the network thread, meaning there's no additional hops, it just happens immediately as soon as Chrome executes it. So a quick example, I'm gonna say I have been known to spend too much time on Facebook, so when I'm at work, I just don't want it to be available at all. So I'm gonna have a simple extension here that requires the web request API, the web request blocking API, and access to Facebook.com. So this is the manifest JSON I mentioned earlier. And you can see I have a background script that I'm going to passively load and have running. My background script is going to receive a details object or a request object that contains details about the request. So this is kind of the passive data that's being exposed to the extension. So in this simple example, anytime I see a request going to Facebook.com, I'm going to return an object that says cancel. So the request will be blocked, and otherwise don't do any special modification. And that's the super simple extension. The way this would look in the declarative net request world is we replace all those permissions with a simple one, declarative net request, with no additional host permissions, no additional ability to inject content. And we now have a rules.json, which will define the network request modification rules that Chrome will execute. Our rules list is pretty simple. All we're going to do is, if we see a request for Facebook.com, we're going to take the action block. That's it. Another major change that is happening in Chrome Manifest v3 is the migration from background pages to service workers. So if you're not familiar with the extension platform, the way it currently works is when you create an extension, one of the core pieces that you have is a background page or background script, which has a page environment. So you're literally running an entire web page headless. It just doesn't render anything, which means that you have the full capabilities of the web in terms of being able to play, say, audio or being able to use event propagation natively in your background page. In the future, we're moving to service workers, which are web technology that's emerging kind of under the progressive web app banner. And it allows you to have a more ephemeral execution environment where your service worker gets woken up in response to events, it has some time that it can execute, and then when it's no longer doing anything, it just gets terminated and then frees up the resources. So this service worker environment is extremely similar to the current event page system. You can have, today in Manifest v2, you can have two types of background pages. You can have a persistent page, which lives forever, or you can have an event page, which is only woken up in response to events. In general, this is kind of a pattern of Chrome trying to provide more performant options, but most people fall back on the less performant version. So event pages have not been as well adopted as we would like. Part of the move to service workers is just cleaning up to use the standards that the web platform exposes. Since Chrome extensions are webby, we want to use the web as our default environment with only the modifications required to enable extensions. So some of the challenges that this move is going to present to developers is they don't have access to DOM with all of the capabilities that involves. It requires a more event-based approach to application development, which you may or may not currently be doing. And given that you no longer have a persistent global environment, you can no longer have state sitting there passively exposed. So let's take a look at a couple of examples. I have a simple extension here that basically is just going to pass a message to the content script that will display somebody's name. I think in these code samples, I left out the content script because it's not that important. But basically, it just has a message handler that receives a name and then logs it. Nothing fancy. So here, the extension currently has persistent true. If you don't explicitly specify persistent false, it is by default true. And then our background script, basically, if we get a message that sets the user's name, then we'll set the global name variable to whatever the name is that we received. And then when you click the browser action button, the icon in the Chrome window, then we will send the name to the content script. That's all that's happening here. It's not terribly fancy. The problem that we're going to have with this in the migration to Manifest v3 is we're not going to have global state anymore. So in order to work around that, we need to tweak it a little bit. Here, we're explicitly calling out that persistent is false, so now we're using an event page. And rather than having a global variable that we're reading and writing, we're using chrome.storage.sync to set the user's name when they pass it in, and we're using chrome.storage.sync.get to retrieve the user's name when we want to send the message to the background page. So this is basically shifting from global state stored in JavaScript to state stored in a persistent place. The next step in the migration is going to be changing from an event page to a service worker. So here we have a script. It's a single persistent background page, or a single non-persistent background page. Here we're explicitly declaring a service worker. And it's worth noting here that in the introduction of service workers, you will be able to use service workers with Manifest v2. This is intended to help developers migrate from the current platform to the new version that we're going to be using. The third, and I think final, change that I want to call out is remotely hosted code. As I said, we're not going to allow you to execute code that isn't part of your extension bundle in the not-too-distant future. One of the challenges that this is going to prevent to developers is that it limits the dynamism that you can have. Some people are currently using this to not ill effect. Like they're doing good things by delivering updates very quickly to users, or to A/B test and make sure that their extension is performing as well as it can. In order to adapt to this, developers are essentially going to need to bundle their third-party code into or bundle the resources that they want to load at runtime, bundle that into the extension, and load it from the extension. So here we're doing a simple, incredibly simple thing where we have a content script that is just going to inject jQuery onto the page. And as you can see, we're loading jQuery from the official jQuery website. All this content script does is create an element, assign the appropriate attributes, and then append it to the parent document. In the new world, we're going to need to explicitly expose the jQuery library using web-accessible resources, and we're bundling the library with our extension. And then when we want to inject it, we just use chrome.runtime.getURL to retrieve a URL in order to load this specific file. The rest is basically the same. And with that, I just want to quickly go through the major changes, again, to the extension platform. We're trying to move towards an active tab style set of permissions. So users are in control of when the extension is running. We're moving away from APIs that leak data, like web request, in order to make sure that as little information is being exposed to the extension as reasonably possible. The web request change here is the first of many steps in this direction. But I think in future versions of the extension platform and additional changes in Manifest v2 or Manifest v3, you can expect that we're going to be trying to tighten up how and when extensions are running and what data they're getting access to. And finally, we're replacing, oh wait, there's a fourth one. We're replacing background pages with service workers, and that's going to have some impact on how extensions are architected and how they approach the job that they're doing. And finally, we're removing the ability to run remotely hosted code through a combination of platform API level changes and Chrome Web Store policy changes. If you are interested in continuing to dig into the extension ecosystem, I'd recommend checking out the Google Chrome or Chrome Extensions Google group, and also checking out the Manifest v3 design document. The design document is public, like almost all Chrome design documents, and the intention is this is the launching off point. This isn't a definitive document, but it's the starting point from which the team is starting to work to actually implement these features. Finally, if you have any feedback on this stuff, as the extensions developer advocate, I'm extremely interested in it. So please tell me so I can help make the extensions platform as good as possible for you and for everyone else. Again, the Chromium Extension Google group, or if you want to reach out to me directly, I'm .proto on Twitter. And you can also schedule office hours to do a one-on-one video-based session or phone call with me using the bit.ly link here. And that is it. Thank you very much.